Here is 6.3.2, solving more complex trig equations. You are going to want to take notes, start a new section, and make sure you highlight or use color when you think you need it. So 6.3.2, here's a special note. When solving, try to manipulate the equation so there's only one trig function involved. So when you guys see, sine and cosine within the same function, try to put it all in terms of sine or in terms of cosine, because that's just going to make it easier for you to substitute and solve. Okay, so this is just kind of extending what we did a couple of days ago. All right, so here's the first example. Solve 2 cosine squared x plus sine x plus 1 equals 0. And I gave you a little hint. Use FPI, which is Justine's way of saying fundamental Pythagorean identity, to write the equation in terms of sine x. So before we can do anything, I have to get rid of this cosine squared x and replace it using FPI, right? Okay, so it'll look like that. So cosine squared x gets replaced by 1 minus sine squared x. And then from there, go ahead and distribute the 2, you guys. So that will go 2 minus 2 sine squared x plus sine x plus 1 equals 0. Okay, and then I'm going to combine my like terms. I'm going to move it over just a little bit so I have space. So my like terms are going to be the 2 and the 1, and that's it, I think, right? So that's 3. And then I have still my negative sine squared x. Negative 2 sine squared x. I don't think I'm going to be able to squeeze this in. Let me move this 3 over. Plus sine x plus 3 equals 0. Now, I don't know if you noticed this right off the bat, but this is actually a quadratic equation now. Even though there's signs in it, do you see that this is a squared term, this is an x term, and this is just a constant? So this is a trinomial. So what I have my students do usually, and I want you guys to do it too, is pretend like these guys are just plain old x's, right? And if that was the case, it would look like this. Negative 2x squared, sine x, nope, sorry, just x, and then 3, right? And then this is completely factorable. So now I can come up here and I can say, okay, so I know this factors, and it is negative 2x and x, and 3 and 1. And because I've already done this, I know how to play with the numbers, right? So you could check this using FOIL, but that definitely gives us the right terms. We want our 3x to be positive so that we can have a positive middle term there, right? Now, once you have the factors, guys, instead of x, plug that sine x back in, right? So I'm going to say, now I know that this is negative 2 sine x plus 3, right? Because it works the same way as an x. It just gets confusing a little bit when you have the sign that you're dealing with. So, and both of those equal 0. I can't really squeeze the 0 in. Okay, so now from here we want to just solve, right? Remember in factoring, you take each factor and you just set it equal to 0 and you solve, right? So I'm going to say, all right, this one would be sine x equals negative 3 if I subtracted the 3, and if I divided by negative 2, that would actually give me just a positive 3/2, right? So I'm kind of skipping a step there. Let me know tomorrow if that confused you. And then this one, it'd be sine x plus 1 equals 0. So if I subtract the 1 from 0, I get negative 1, right? And then from there, I'm just solving, right? I'm just looking at where is the sign 3/2 and where is the sign negative 1, right? So pretty straightforward and easy from then on. Okay, so I just wanted to show you mostly how to get it to this point. All right? Okay, and then this one. Solve by substitution in 0 to 2 pi. So remember that just means we're only rotating one time around the unit circle. Okay, we're not having to do the plus 2 pi n thing. And then here is our equation. So 8 cosine squared x equals 4 cosine x. Okay, so right now as it stands, I can't really do a whole lot. So what I need to do is I need to subtract the 4 cosine x and get it over here. Because if I get them on the same side, I can at least take out a cosine x, right? I'll be able to factor some stuff out. So we're going to set this equal to 0 now because that canceled. So make sure that you still realize it's an equation. So you can't get rid of that 0, right? And then these are not like terms, you guys. Be really careful. One of them is cosine squared and the other is just a cosine. So all I'm going to do is write them next to each other, but then hopefully you see that you have a cosine in both of them, as well as 4 and 8, right? Both of those can divide by 4, and then cosine x can come out of both, right? And then that would leave me, if I divided by 4 cosine x, I would have 2 cosine x in that first one left over, and I would have just a 1 for that last one. Okay, so I'm taking out that common factor, greatest common factor. And then from here, because they're now multiplication right here, I can just solve each one individually like I did on the last one. So I can take 4 cosine x and set it equal to 0, and 2 cosine x minus 1 and set it equal to 0. And then from there, I just want to solve, right? So here I would say, okay, well, if I divide by 4, it's not going to do anything. So cosine x equals 0. Here I would add the 1 and divide by 2. So this one's going to be cosine x equals positive 1/2. And then I can find all my answers for that, guys. The cosine is 0 at pi over 2 and at 3 pi over 2. Right? So that's on the x-axis. Sorry. And then on the y-axis, my fault. And then cosine x equals 1/2 at pi over 3 and at 5 pi over 3. So those are your 4 answers for that problem. Okay, so again, it was already all in terms of cosine, and all I'm doing is trying to get it all on one side, in this case, so that I can factor. Okay, let's do another one. So here is sine squared x plus sine x equals 2. So again, I have the signs on the same side. So for here, I actually left the 2 where it was. You could subtract the 2 and factor, but I think it's extra work because you're going to end up solving anyway. So on this one, I went ahead and I took a sine x out of both of these because they have that in common, right? And then that leaves me a sine x plus 1 equals 2, right? And then from here, I can go ahead and solve both, right? So I can say, okay, sine x equals 2, and sine x plus 1 also equals 2. So if I simplify this one, I'm ending up subtracting the 1. So sine x, I left my n off my sign there, sorry. Sine x equals 1. And here, sine x equals 2, right? So those aren't my answers, but that's my simplified down version. So now I can just need to solve it, right? So this one actually is no solution. Do you know why that is? Okay, think about it. If you're on the unit circle, can you have a sign value that's bigger than 2? You cannot. Yeah, this one still solves, sorry, on 0 to 2 pi. So because it's on 0 to 2 pi, I can't get a solution that's bigger than this without stretching the sine function. And hopefully you can tell here no stretch is happening to the sine function, right? So this one's no solution. All right? And then this one, I can actually get an answer, right? The sine x is equal to positive 1 only straight up at pi over 2. So that's the only solution for this one. Okay, next. Sine x times cosine x plus 1. So on this one, you can see that you have 2 different values happening, but the good news is it's already factored for you. So I'm actually ending with 2 really pretty easy ones. Sine x equals 0. That's going to be my first one. As long as this is multiplication, guys, this is legal, right? Sine x equals 0. And then the other one is the inside of the parentheses, which is this. Cosine x plus 1 equals 0. And I'm just going to solve both of them. So minus 1 here, right? So where is the cosine of x equal to negative 1? And where is the sine of x equal to 0? right? So sine of x equals 0, I think we just did that one, didn't we? Where is it, guys? Sine of x is 0. Oh, y value. We just did sine of x equals 1, didn't we? So this is at 0, at pi, and at 2 pi. Okay, so 3 possible answers for that, because these brackets include 0 and 2 pi, right? And then cosine x equals negative 1. Where is the cosine negative 1? Well, that also happens at pi. So because that's a repeated answer, we don't have to list it twice, right? So we could just list one of our pi's, and those are your 3 solutions for that one. And then this one, super easy, just a refresher for your test tomorrow so you remember. When you're trying to solve tangent x and you have something by itself, you want to subtract that and get it alone. And then just rewrite your tangent. No reason to change it. It's the only thing there, right? And then look at your handy-dandy little chart. Or you can realize that this tangent happens at the coordinates where it's a half and negative 3 halves for your values, right? So it's going to be in quadrants 2 and 4. And, 3 and 4. And so then we know that our 2 coordinates that we need are 5 pi over 3 and 2 pi over 3. And that's it, you guys. Don't forget I'm checking your notebook tomorrow, so make sure it's really organized and you take the time to get it together. Okay, thanks.